What time is it right now? That's a pretty easy question to answer. Just look at a clock or your phone and you'll know. Time is a basic part of our everyday lives. You don't do anything without time being involved in some way. But how does time work? I mean, how is it made and how does it pass by? Why can't we see the past or the future, but only the present? Time is more complicated than you think. It is the fourth dimension of our universe. You may think that sounds wrong since we obviously live in a three-dimensional world. We can move back and forth, side to side, up and down, and any angle in between. We move on the X, Y, and Z axes. That is what three-dimensional, or 3D, is. There are three dimensions to move in. And that is true for everything in space. It exists in three dimensions. But this three-dimensional space exists in a fourth dimension that we can't see, time. You may wonder, why can't we see this fourth dimension? Think of it like this. In a two-dimensional universe, that is, one that is flat and only has the X and Y axes to move on, can't see a 3D object for what it is because there isn't a Z axis in that universe. So as the 3D object moves on that axis, you can't see the full thing since it can't exist in two-dimensional space. That is like our universe in the fourth dimension. It is moving through the fourth dimension on an axis that we can't possibly see due to the limitations of our universe, but it's still there. Now, remember that 3D objects in a 2D space comparison I just gave, because I'll be going back to it later. Before I get further into this topic, we need to understand what spacetime is. Space and time move together. You can't have one without the other. When you move through space, you move through time. For example, as the Earth orbits the Sun, time passes, and as time passes, the Earth orbits the Sun. They are one in each other. Spacetime is often referred to as a fabric, which you will understand why later. Now, to go back to my comparison of a 2D universe with the third dimension being time. So this is a simplified explanation of how time works in our universe. Think of a cube, a three-dimensional object. But this cube represents a universe that sees everything in two dimensions, like how we can only see 3D in a 4D universe. This cube is made up of layers and layers of stacked two-dimensional squares. Each of these squares are a part, or fabric, of space-time and represent a part of time. And time passes by as we move up the cube. As we move up, the layers below become the past, and the layers above are the future. Once we pass through the layers, we can't see them again, and we can't see the layers above either. We are only able to perceive the one layer that we are currently on. That is why we can only see the present and not the future or past. The reason I explain this in three dimensions is because if I start trying to explain how 3D objects move in a 4D space, we will all be very confused, including me. The fourth dimension is impossible to visualize because we have never seen anything in the fourth dimension before. So, remember, this is a simplified version of our universe, a 2D universe with the third dimension as time. Here is an example from a video on YouTube that explained time in an even simpler form. There is one dimension and the second dimension is time. See this X shape? This represents two objects, a red object and a blue object, approaching each other, colliding, and then bouncing off each other. This is the past, present, and future, all seen at once. This is what happened, what is happening, and what will happen. This is how it would look in the cube we were just talking about. Now, if we place a sheet over top of this X with one slit in it representing the present, as it moves up, we can see what is currently happening. As we move through time, the objects approach each other, collide, and then bounce off each other. You see now how we can only see what is happening in the present. The black squares are the past and future, and we can't go backwards into the past to see it again, and we can't see the future until we approach it. This is like in our universe. You can't see the past or future, only the present. All you can do is wait, unless you are able to see in 4 dimensions, then you will be able to see the past and present and a possible outcome in the future. So far we know that time is the 4th dimension, and we move through it only being able to perceive 3 dimensions. These visible dimensions are all a part of spacetime. It doesn't stop there though. Going back to the cube analogy, spacetime isn't just a bunch of flat surfaces stacked on top of each other. These flat surfaces curve and bend due to large gravitational bodies such as a planet or a star. It stretches, much like a fabric. The curvature of spacetime can be easily visualized using a trampoline and a heavy ball. If you place the ball in the middle of the trampoline, it stretches the fabric, causing certain strengths of gravity depending on the mass of the object. The more it stretches, the stronger the gravity. This stretch is also what causes objects to orbit around these large bodies. They are pulled in by the gravity caused by the stretch of spacetime. How do we know that spacetime can curve? What proof is there? Well, we have to remember that these are only theories, and while they have a lot of evidence to back them up, we still don't know everything about how our universe works. There is so much more out there that we haven't even begun to understand, like dark matter and dark energy, but that's a topic for another time. One way we have been able to observe the curvature of spacetime around large celestial bodies is by looking at how light behaves around them. Light appears warped around these objects because the curve of spacetime curves any light near it. Now, how does this stretching and curving of spacetime affect our cube that we made before? Well, the more a celestial body, such as a planet, stretches and curves spacetime, the slower time moves on this planet. This effect is known as gravitational time dilation. Now, how does that make any sense? Why would time move slower where spacetime is stretched more? Well, it all has to do with the equation speed equals distance over time. Speed is the speed of light, which is constant. Light always moves at a speed of about 300,000 kilometers per second. That never changes. So, when a heavy object bends spacetime, it also bends light, but the light still moves at the same speed as before. So if the distance for light to travel is longer, then the time has to slow down since the distance has increased. Distance over time always has to equal the speed, which is the speed of light. If it was a shorter distance, for example, light traveling on an object not as heavy, then the time will speed up. If the distance is longer, time slows down, and if the distance is shorter, time speeds up. Okay, so we now know that the more spacetime curves, the slower time is on that heavy object curving it, because time has to slow down to accommodate for the increased distance. Distance over time always has to equal the speed of light. But why does it have to equal the speed of light? What does light have to do with time? Well, light is how we see anything in the universe. If there was no light, we wouldn't be able to see anything, including seeing time pass by. So, knowing light always moves at a constant speed of about 300,000 kilometers per second, when it has to move a long distance, it will take longer to reach us, making it appear that time is moving slower. Time is not a constant like light is. Time is relative to the observer. So, if someone were to stand on that heavy planet curving spacetime, they wouldn't see themselves moving slower than everything else. They would be moving at a normal rate while everything else around them is moving faster. The movie Interstellar did a good job at portraying this effect in the scene where they land on a planet where 1 hour on that planet is equal to 7 years on Earth. While on that planet, they didn't perceive themselves moving really slowly. They experienced time the same as they would on Earth. When they returned to their ship, while they only experienced a few hours passing by, they had actually spent over 20 Earth years on that planet. If you still don't quite understand why time moves slower when spacetime is curved, let's go back to the cube analogy. You can think of it like this. When the lines are bent downward, it'll be a bit behind as we move up the cube, which is time moving slower. Now, let's talk more about light. As we already know, light affects how we see time. It always travels at a constant speed, and this means that light doesn't travel instantaneously. It takes time to reach a certain point. For example, we actually see the sun 8 minutes younger than it really is, since the light traveling from the sun takes 8 minutes to reach us on Earth. That sunlight you feel when you go outside took 8 minutes to get to you. Also, when we look at galaxies millions of light years away, we are actually seeing those galaxies as what they looked like millions of years ago. A light year is how far light travels in one Earth year, which is about 9.5 trillion kilometers. The closest galaxy to our Milky Way is the Andromeda Galaxy, which is 2.3 million light years away from us. So when we look at it, we see it from 2.3 million years in the past. We see it from in the past because that's how long it takes for the light to travel from the Andromeda Galaxy to Earth. And, like I mentioned before, we can't see time pass without light. Remember, light also affects how we see time pass. Because until the light reaches us, we can't see what's going on, including seeing time pass by. If you were to travel to that galaxy at light speed, it would take 2.3 million years to get there, though you would experience it as if no time passed at all, but that's a topic for another time. You might be wondering, who could have ever thought up all of these ideas for how the universe works? You can thank Albert Einstein for his incredible theories about the universe. His theory of general relativity and special relativity are the theories that space and time move together, and also discusses how spacetime works and how the speed of light is constant. There are so much more to these theories, such as what happens as an object approaches the speed of light when traveling. I recommend you continue reading about this theory since it is very interesting. To sum everything up, time is the fourth dimension, and space, being 3 dimensions, moves along this fourth axis, which is how we are able to see the present, but not the past or the future. This spacetime can curve from heavy celestial bodies like a star or planet, and affects how we see time pass on these bodies. Light also accounts for how we see time. We see objects that are many light years away for how they looked in the past. Time is a very strange and confusing topic. Time is more complicated than you think. So next time you look at your watch, think of all the factors that make it say what it says.